Hey folks, in this video we're going to look at the reaction of bismuth oxide with carbon to determine the amount of bismuth formed in this reaction. So we have a list here of the approach that we're going to take. The first thing we're always going to need to do when we're doing a stoichiometric calculation with a reaction is first make sure the reaction is balanced. And this reaction so far is not balanced, but let's take a look at it. So we've got on the reactant side, we've got 2 bismuth atoms, and so that means we're going to need to put a 2 in front of the bismuth on the product side. We've got 3 oxygen atoms. All right, so let's put a 3 in front of the carbon monoxide on the product side. And now if we're going to note how many carbons do we have, well, we've got 3 carbons on the product side. All right, so we're going to need 3 carbons on the reactant side. So we're going to add a 3 in front of that. So now we have a balanced reaction, which means we have the same number of atoms on both sides, the reactant and product side. All right, so our goal here is to first compute the grams of bismuth in this reaction, okay? And so that means that the first thing we need to do in a reaction like this is figure out the moles of the given substance, which in this case is the bismuth oxide. So, so if we take a look at this, we've got 283 grams of the bismuth oxide. And so in order to calculate the moles, what do we need to do? We need the molar mass in order to do that. So we're going to need to figure out the molar mass of our bismuth oxide in order to calculate the number of moles. All right, so we're going to go to the periodic table and we're going to figure this out. First thing we're going to do is go to the periodic table and look up the molar mass of bismuth. And we'd look up the molar mass of bismuth. And we see that that's 208.98 grams per mole. All right. And then we also need to look up the molar mass of oxygen. And we're going to see, again, depending on our source, sometimes it's listed as 16.00. In this case, I'm going to use one with 3 sig figs. Whatever is in the periodic table you're going to be using is fine with this. So it's 15.999 grams per mole is what I'm going to be using here. All right, so now let's figure out the molar mass. Well, to figure out the molar mass, we're going to note that we've got 2 moles of bismuth in our bismuth oxide because we've got a subscript of 2. So we're going to take 2 times 208.98 grams per mole and add to that 3 moles of oxygen because we've got a 3 in our formula. Right here is a 3. All right, and we're going to multiply that by 15.999 grams per mole. All right, and we're going to add that together. And when we do that, we're going to get a total molar mass of 465.958 grams per mole. And the number that you get might be a little bit different depending on how many sig figs you're using in your molar mass of your elements, but it should be real close to that. All right, so now, and we haven't considered sig figs here, we won't until the very end. So that's our molar mass. So how do we figure out the number of moles? Because here we are in still step 2, compute the number of moles. And so how do we figure that out? Well, we've got a given of 283 grams here. So what we're going to do is we're going to figure out the number of moles of our bismuth oxide is going to be equal to the 283 grams divided by the molar mass, or if you want, we can write it this way. 1 mole is 465.958 or 96 grams per mole. And so that gives us the number of moles of our bismuth oxide. All right, and that's going to come out to 0.6, and we're going to have 3 sig figs here, 607 moles of our bismuth oxide. All right, so that completes step 2. Now we're trying to figure out bismuth here, and we're going to note that there's a 2 in front of our stoichiometric coefficient. So our ratio is going to be 2 moles of bismuth to 1 mole of the bismuth oxide. All right, so that means we're going to figure out the number of moles of bismuth by using that ratio. So I've got 0.607 moles of bismuth oxide, and our ratio is 2 moles of bismuth to 1 mole of bismuth oxide. And again, you know, we use dimensional analysis here. We're going to know moles of bismuth oxide will cancel. So we're going to get an answer in terms of moles of bismuth times that, which is going to be 1.21, again, rounding off, of bismuth. Okay, so now that we have the moles of bismuth, we need to figure out the mass of bismuth. All right, so we have just completed step 4 here, so now we're figuring out that. In order to do that, we need to know the molar mass of bismuth. Well, you know what? We already did that, right? So here's our molar mass of bismuth, and so we're going to figure out the mass of our bismuth, which is equal to our moles multiplied by our 208.98 grams per mole of bismuth. And again, using dimensional analysis, that cancels out. So we just multiply that through, and we get 253.8 grams of bismuth, which, if we're going to be using sig figs, we're going to have 3 sig figs, so that's 254 grams of bismuth. So that's the mass of bismuth that we've got. Now, what if we want to figure out the carbon monoxide? All right, so if we're going to figure out, so at this point, all right, so this part right here is the part where we are calculating the amount of bismuth. If we want to do carbon monoxide, we're going to do the same kind of thing. We're going to note the mole ratio. So we go back here, and our mole ratio for carbon monoxide, 3 moles of carbon monoxide per mole of bismuth. So we're going to do the same thing down here for carbon monoxide to get the number of moles. So it's going to be this 0.0607 moles of bismuth oxide, and our mole ratio is 3 moles of carbon monoxide per 1 mole. And so for carbon monoxide then, we're going to get 1.82 moles. All right, and now for the mass, we need to know the molar mass. So what's the molar mass of carbon monoxide? Well, we look it up in the periodic table. And so we're going to have 12.01 grams per mole of carbon plus 15.999 grams per mole of oxygen, which we had before. And so the molar mass of carbon monoxide is then 28.01 grams per mole. So we're going to use that value here, and we're going to take our 1.82 moles of carbon monoxide, multiply it by the molar mass of 28.01 grams of carbon monoxide per mole of carbon monoxide. Again, dimensional analysis, the moles cancel. And we're going to end up with a mass. I'm sorry, I'm having problems pulling up my calculation results here. There we go. 51.04. And again, if we're using 3 sig figs, 51.0 grams of carbon monoxide is what we produce. So now we calculate the mass of our products in this particular case. And again, I will note, and this is something we'll talk about a little bit later, the reaction said excess carbon. So we didn't actually specify how much carbon we had in this. We just, excess means we've got more than enough carbon to react with all of the bismuth oxide. Now later on we'll be doing calculations where we will look at the mass of both the bismuth oxide and the carbon, or both reactants, and then we'll have to figure out what the mass of our products is going to be when we have the mass of both reactants. It's called a limiting reactant or limiting reagent problem, and it is something that we will be looking at later, but we're not going to worry about that right now. So I hope this is clear. Let me know if you have any questions.